All right. Hello, my Maine West Math 3 students. If you're getting this, Mr. Butterfield has been called to jury duty. Yay. So I will be downtown tomorrow instead of being in class. And let me tell you, I'd much rather be in class, but I'm going to do my thing. Go down and do jury duty. Let's see what happens. All right. So I need to make a video. I'm doing this video the night before. Hopefully this all works. I got to put a couple videos together. The app that I'm using only lets me do like less than 15-minute videos, so there'll probably be a part 2 to this. All right, so learning targets. You're going to create geometric or geometry symbols, notation in order to communicate. We've been doing this the last couple of days. How do you name a line? How do you name an angle? How do you name an array? We've been doing this. I can create visual geometric representations using appropriate labels and markings to represent geometry relationships. We did that with the slideshow where it told you to draw something and then you guys practiced drawing it out. I can create an equation to model geometric relationships for segments. We're going to do that right away in the lesson down below. I can evaluate an expression to determine the length of a segment or measurement of an angle, or the measurement of an angle. So they're calling it task 7.2, but this is really the 7-2 notes for us. So if I was in class, this is the part I'd just be leading you guys through this stuff as we go. So picture you got a map of the state of Georgia. They're going to demonstrate segment addition and subtraction. How do we use these segments in order to set up little math? You're going to do modeling of geometric relationships for segments. Suppose you're driving on a trip. It starts at Albany, down here at point B, and you're going to Athens, Georgia, point A. You plan to stop for lunch after you drive for a few hours. You know that the distance from Albany to Macon is 80 miles, and the distance from Macon to Athens is 90 miles. Whenever I teach my geometry students, let me focus this. Whenever I teach my geometry students, I usually tell them, hey, if they give you numbers and stuff like that, go ahead and label your diagram. So the first part of it is 80 miles, and the second part of it from M to A is 90 miles. How far are you going to drive total in your trip? Not a real tough question. You put this one and this one together. That's 170 miles. 170 miles. Now, how did you get that answer? That's what they mean by taking this geometry picture here and coming up with a model. By model, they just mean coming up with an equation here. You're going to do the first part of the trip is 80 miles. Second part of the trip is 90 miles. And 80 plus 90 is how we came up with 170 miles. So that's what they mean by segment addition. Segment addition. In order to demonstrate that, maybe without even using numbers at all, they're going to first get down these two different concepts at the bottom. I really like that. Whoever typed these notes up, this is actually a pretty important subject, and I've been teaching geometry a while. Naming a segment is different from describing the length of a segment. Two different symbols for that. So we've been doing this. Hey, this is segment CT. If I want to name the segment, use a segment symbol, CT. You put a bar over the top. And you have to use the endpoints. So if there was other letters, like this was A and this one's B, you wouldn't use A and B. If you want to name the whole segment, one end of it is C, one end of it is T, call it segment. And you would actually say it, or you would read segment, CT is how you would say it. The length of a segment is done differently. If they're talking about the 65 inches here and they want to know how long it is from C to T, you put no symbol over the top. You just say CT to describe the length of a segment, no symbol over the top. You say CT equals 65, and inches is that double tick mark. Important fact, to indicate you want someone to determine the length of a segment, you leave the segment bar off of the segment. And that's true for line or array or any of those things. But if I wanted to know how long is it to go from C to T, you might see it on a test or a quiz. It might just say this, hey, CT equals question mark. That means, hey, you're supposed to figure it out. And answer is a number. some sort of a number. Could be an algebra expression, but it's some sort of a number to describe the length from C to T. In fact, I should say algebra segment. I know on the next page there's some algebra segment type of ideas. All right, copy that down, turn the page. All right, the segment addition postulate. Now, a postulate in geometry just means rules. So don't get thrown off by that. That just means it's a rule in geometry. Look back at the map of Georgia on the first page. Since we can use segments to model real world, this is what they mean by modeling, real world scenarios like distances and lengths, we are often interested in measuring how long a segment is. Now in boldface it puts as long as B is between, circle between, A and C. Means they're all along the same line or ray or segment in this case. All right, so if I'm having you go up to the board and I say, hey, there's a point A here and a point C here, and I draw a point B like this, and me and you are just talking, it's not really about geometry or anything like that, and I say, hey, B is between A and C. A lot of kids would understand what I mean. Hey, B is between A and C. But in geometry, if you say the word between, that means they're all in the same line. They gotta be straight across. And it can't go like A to B to C. That would not work. They gotta be collinear is what they call it. They gotta be all in a row, straight line, anytime they use a word between. As long as B is between A and C, we can add segments together like we did on the map. Write the addition segment for this segment below. I'm sorry, the addition statement for this segment below. So the whole thing is called segment AC. And the length of AC, so I'm not putting a symbol on top, whatever that number would come out to be, it would equal this segment here, whatever this number length is, AB, plus this number length, BC. So the length of AB plus the length of BC equals the length of AC. And we're going to use that in a few models directly below that. Find the length of PR. So PR is the whole thing. So to figure out what PR is, I just need to take this segment plus this segment. So PR is actually equal to PM plus MR. Substitute the numbers in there. So PR is equal to 8.5 plus 4.2. Now you might be rolling your eyes a little bit and going, I don't need to write all that. I can add those two things together. Sure, they're starting out with some pretty simple, straightforward examples. But 8.5 plus 4.2, 12, gives me 12.7. And if they use inches, miles, feet, yards, whatever, you would add that on. After that, inches, feet, miles. If they don't use it, then you don't have to put anything. You don't have to put any units of measure. Same thing in this one. No units of measure. My answer won't have a unit of measure. Now this time they give me the whole thing. So AC is equal to, I meant to call it AB, but if I put the letter B first, it still means the length. BA plus BC. So this is 54. This is 25. This is missing. We'll call it X. That would be the number that goes there, or question mark, or whatever you want to call it. So to get that answer, just subtract 25. Subtract 25 on both sides, and I get 29 is equal to X. And BC, or you can say the length of BC is equal to 29. All right, so far so good. So they're going to build it up to the next one. The next one now, we're moving into algebra, actual algebra type stuff, tied in with the geometry. Same idea though. Write an equation you would need to solve in order to determine the value of X if AC is 27, so 27 is not on the drawing, let's put it on there. 27 is from beginning to end. AB is 2x plus 3, and BC is 3x minus 1. We know from the pictures up above, if I'm just sort of copycatting what happened up above, I know that AC is equal to AB plus BC. Let's plug in what we know, the 27, the 2x plus 3, the 3x minus 1. So 27 is equal to 2x plus 3, that's the AB part, plus the BC part, 3x minus 1. Now there's my equation. So I use a geometric diagram. I made a model meaning this equation. Now I got to solve. I got to determine the answer. I got to figure out what x is. So determine the value of x. That just means solve it. Combine like terms, 2x and 3x is 5x. 3 and minus 1 is a plus 2 equals 27. Now I got to take things to the other side, so I have to undo whatever's happened in x. So if it's a plus 2, I'm going to subtract 2 to the other side of the equation. Keep the balance. 25 equals 5x. Divide by 5. And I get 5 is equal to x. 5 is just the number that plugs in for x. But if I plug it in here, I'll get a number. If I plug 5 in here, I'll get a number, and add the two numbers together should equal 27. So how long is AB? They wouldn't even actually say how long is AB. They would usually just say, hey, AB equals what? That means you have to figure out how long it is. And it just means plug in the number 5. 2 times 5 plus 3. You're just plugging it in. 2 times 5 is 10. 10 plus 3. AB, I should put that down here. AB is equal to 13. AB equals 13. And they said AC minus AB. So AC is the whole thing minus AB. I would be left with BC. AC is 27. AB we just figured out is 13. So that would equal 14 for BC. All right, problem number 4. All right, getting close to where I have like a time limit on this. It says make a sketch that matches this description. E is between points D and F. E is between points D and F. So because it used the word between, I know that E is somewhere on this line. Most kids are going to pick dead center, but you don't have to pick dead center. All right, so D is here, F is here. If DE is equal to 8, put it on there, and EF is equal to 25, put it on there, find the value of DF, the length of DF. Oh, that's not too difficult at all. Find the length of DF. So that would be 8 plus 25 is equal to DF. Now I need to pause it right here. This is the end of part 1. I have to keep these videos kind of short. I'll throw the rest of the notes on part 2. Jump over to part 2 now.